Acids and bases are not only something we use in the kitchen, they have many more applications. In this presentation, we will look at the foundational knowledge of acids and bases and how they are utilized in a variety of fields. Additionally, we will investigate their chemical characteristics and how these capabilities influence their usage in chemistry. Understanding acids and bases is essential to comprehending the chemical reactions that occur in our everyday life, from the foods we eat to the cleaning products we use. The properties of acids and bases affect many areas of our lives. Acquiring knowledge of these components and their characteristics will allow us to understand how they are being applied in various industries. Acids are widely used in many areas, particularly due to their peculiarity of being able to corrode some substances and react with metals. Furthermore, some indicators like litmus paper are sensitive to acidic solutions and change color when exposed to them, usually from blue to red. All these properties make acids very useful in many applications. Bases possess distinctive qualities such as the proclivity for accepting protons or donating electron pairs. They usually have a bitter taste and a slippery texture. When blended with water, bases create hydroxide ions generally known as O. Examples of bases frequently found in households are ammonia and sodium hydroxide. Having an extensive understanding of the properties of bases is useful for different purposes. The pH scale is a significant instrument to measure the acidity or alkalinity of a substance. It ranges from 0 to 14, with 7 indicating neutrality. Acids are compounds that release hydrogen ions once dissolved in water and are acidic in taste. On the other hand, bases release hydroxide ions instead of hydrogen ions and are known for their bitter taste and slippery feeling. The practical uses for acids and bases are various and must be used with caution. Neutralization is a chemical process in which an acid and a base are reacted to form a salt and water. Proton transfer occurs between them, resulting in both acid and base being completely changed into something else. As this reaction is fundamental to our understanding of how acids and bases behave, it has a large impact on chemistry education. Acids tend to have a sour taste and can turn blue litmus paper red, while bases are usually bitter and feel soapy. By studying neutralization, we gain a better insight into the way these two substances interact, as well as recognizing the various practical applications of acids and bases in laboratory and real life. According to the Bronsted-Lowry theory, an acid is defined as a proton donor and a base as a proton acceptor. This definition thus expands beyond aqueous environments and covers any environment where the transfer of protons takes place. Svante Arrhenius proposed the Arrhenius theory in 1887, which is one of the most significant theories in acid-base chemistry. Under this theory, acids are considered as substances that split into hydrogen ions in water, while bases break down into hydroxide ions in water. This theory has been a major factor for comprehending the actions of acids and bases if found in aqueous solutions. Bases are substances capable of accepting a proton and establishing a bond. In aqueous solutions, bases have a bitter taste and augment the concentration of hydroxide ions. Bronsted-Lowry theory explains the reaction of acids and bases which produce new compounds. This theory is significant for comprehending many of the acid and base applications. Lewis theory is a crucial concept when comprehending acids and bases. An acid is described as a compound that can take up a pair of electrons to create a covalent bond. This expansive description gives a deeper understanding of acid-base responses. In comparison, a Lewis base is classified as a material that contributes a couple of electrons to form a covalent bond, which clarifies how bases interact with acids. Acids and bases are compounds found in many items from food to medicine. Strong acids are more powerful and have a lower pH level, dissociating completely in water to produce a high concentration of hydrogen ions, with hydrochloric acid and sulfuric acid as two examples. Weak acids with a higher pH level partially dissociate in water with acetic acid in vinegar, and citric acid in citrus fruits as well-known ones. Understanding the difference between these two types is important for practical applications in life. Bases are classified as either strong or weak, depending on their properties and applications. Strong bases completely dissociate in water and form hydroxide ions. Sodium hydroxide and potassium hydroxide are two examples of strong bases. These compounds have a bitter taste, a slippery feel, and can be corrosive. They also conduct electricity well. Weak bases, however, only partially ionize in water, meaning they do not fully dissociate. Examples of weak bases include ammonia and organic amines. Acid-base indicators are important for correctly figuring out the pH of a compound. Litmus paper test phenolphthalein indicator and universal indicator are frequently used acid-base indicators. Litmus paper test changes color when it interacts with a substance, showing its acidity or alkalinity. Phenolphthalein indicator is another prevalent indicator that differs in color with the acidity or alkalinity of a solution, while universal indicator offers a broader scope in finding out the acidic or basic nature of a substance from the color changes seen. Acids and bases can be applied in many different areas, from household cleaning products to food and beverages. They play an important role in our everyday lives. And in industry, they are used in the production of fertilizers, dyes, and pharmaceuticals. Furthermore, they can be used to give food a tangy flavor or for food processing. This presentation aimed to provide a better understanding of how acids and bases are used and their various applications. Thank you for listening.